Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Researchers from the University of Auckland calculated that 74 metric tons of microplastics are dropping out of the atmosphere onto the city annually, the equivalent of more than 3 million plastic bottles falling from the sky. The study, published in Environmental Science Technology, indicated that large numbers of microplastics in Auckland's air are of extremely small sizes, raising concerns about the potential for particles to be inhaled and accumulate in the human body. Researchers around the world are likely to have dramatically undercounted airborne microplastics, says lead author Dr Joel Rindelaub, of the School of Chemical Sciences at Waipapa Taumata Rau, University of Auckland. The levels found in Auckland's air were many times higher than recorded in London, Hamburg and Paris in recent years because scientists in the new study used sophisticated chemical methods to find and analyze particles as small as 0.01 of a millimeter. The mean, average, number of airborne microplastics detected in a square meter in a day was 4,885. That compares with 771 in London, reported in a study published in 2020, 275 in Hamburg, 2019, and 110 in Paris, 2016. Future work needs to quantify exactly how much plastic we are breathing in, says Dr. Rindelaub. It's becoming more and more clear that this is an important route of exposure. The study is the first to calculate the total mass of microplastics in a city's air. Waves breaking in the Hauraki Gulf may play a key role in Auckland's problem by transmitting waterborne microplastics into the air. That effect seemed to be at work when Rindelaub and his colleagues, including PhD student Wenxia Fan and Professor Jennifer Salmon, recorded increased numbers after winds from the Gulf picked up speed, likely leading to bigger waves and more transmission. The production of airborne microplastics from breaking waves could be a key part of the global transport of microplastics, says Rindelaub. And it could help explain how some microplastics get into the atmosphere and are carried to remote places, like here in New Zealand. Particle sizes change with wind direction. When winds passed over the Auckland city centre, the microplastics downwind were larger, indicating the plastics had gone through less environmental aging and came from a closer source. Polyethylene, PE, was the major substance detected, followed by polycarbonate, PC, and polyethylene terephthalate, PET. Polyethylene and PET are packaging materials while PC is used in electrical and electronic applications. All three are also used in the construction industry. In the research, microplastics falling from the air were captured by a funnel and jar in a wooden box on a rooftop at the Central City University campus. The same setup was in a residential garden in Remuera. Almost all of the microplastics were too small to be seen by the naked eye. Scientists identified the smallest particles by applying a colored dye that emitted light under certain conditions. A heat treatment was used to analyze mass. The smaller the size ranges we looked at, the more microplastics we saw, Rindelaub says. This is notable because the smallest sizes are the most toxicologically relevant. Nanoplastics, the smallest particles, can potentially enter cells, cross the blood-brain barrier, and may build up in organs such as the testicles, liver and brain, the paper says. Microplastics have also been detected in human lungs and in the lung tissue of cancer patients, indicating that the inhalation of atmospheric microplastics is an exposure risk to humans, the paper says. The plastics have also been detected in the placenta. The paper, co-authored by Professor Kim Dirks, Dr. Patricia Cabedo-Sans and Associate Professor Gordon Miskelly, called for standardization of reporting metrics so studies of airborne microplastics could be better compared. The paper's introduction says, over the last 70 years, 8.3 billion metric tons of plastic have been produced globally. Only 9% have been recycled, with the rest either incinerated or released into the environment. Fibers dispersed by washing synthetic clothes, fragments shed by car tires and washed by rain into the ocean, and bottles floating down rivers are just some of the ways plastic is added to the weathering and aging breaks plastic down into ever smaller particles. The experiment was carried out over 9 weeks during September, October and November in 2020. Wenxiaofan, Jennifer A. Salmond, Kim N. Dirks, Patricia Cabedo-Sans, Gordon M. Miskelly, Joel D. Rindelaub. Evidence and mass quantification of atmospheric microplastics in a coastal New Zealand city. Environmental Science Technology, 2022, doi. 10.1021, AX. Est. 2C05850 University of Auckland. Microplastic pollution swirling in city air. Millions of plastic bottles per year. Science Daily. Science Daily, the 12th of December 2022. ift.tt/GME0. University of Auckland. 2022, December 12. Microplastic pollution swirling in city air. Millions of plastic bottles per year. Science Daily. Retrieved December 12, 2022 from ift.tt/GME0 University of Auckland. Microplastic pollution swirling in city air. Millions of plastic bottles per year. Science Daily. https://ift.tt/GHZWMY0. Access December 12, 2022. Thanks for watching. Please subscribe my channel for more videos.